Hi, this is Professor Cummings, and this is a video for Zach. He's a student of mine that emailed me a question on planetary gears. He's out on rotation right now and sent me this email. I guess just a matter of curiosity or something that he's working on while till the next semester starts. What it says is, I do not understand on what conditions that the outermost gear, or specifically the internal ring tooth gear, would be static or left to move freely on a rotation about the center of the arrangement. I'm looking into planetary gearing and how or why you benefit from having both the input and the output shaft collinearly aligned. Also, what the ratios are and how that is calculated. Any and all help you can provide would be greatly appreciated. Well, stick around for this video and I will go through Zach's question, go through Zach's letter, and try and one by one get you up to date on planetary gears, why you use them, what their application is, and as well as the different rules behind planetary gears so that you have a better understanding to go out and pursue this information. Alright, so let's start with the basics. Over on the left side of the screen, I've got just a little animation of planetary gears, or a planetary gear set. Over on the right, what I have there is just the planets rotating about the sun. And it kind of shows you where everything got their name from. So you got the sun in the center of the system, and all the planets rotating about it. With planetary gear sets, you've got the middle, which is a sun gear at the center, and rotating about it are the planetary gears. Now, the planetary gears are all held in, this whole system is held into place with this outermost ring known as the ring gear or the annulus. The definition is planetary gears, aka epicyclical gears, are gears mounted so that the centers rotate about each other. You get the ring gear, which is the annulus, the planet gears, which is rotating in the center about the sun gear in the center, but there's one thing that doesn't show up in that animation, and there's something called a carrier. Now what the carrier does is it's actually the mounting plate or the bracket that holds all of the planetary gears. And when you do your calculations and when you consider how planetary gears actually work in their application, what you end up with is calculating the rotational speed around the carrier itself. So that's a very important component, a very important piece of information to keep in mind. You're looking at how fast this carrier is rotating along with these planetary gears. Now, along with these planetary gears, how all the components are laid out, there's 5 different rules that I want to go over for planetary gearing. So 5 laws of planetary gearing. The first is neutral. So that is when you have an input and an output and you're not getting any reaction. So similar, so the same concept of your car. So your engine is running, but you don't have any engagement, and but you've got no input and output actually reacting to the system. The next rule is overdrive, and that is when your carrier is the actual input to the system. The next is underdrive, is when your carrier is the output of the system. Reverse, that's when your carrier is the reactionary, otherwise it's not engaged. So it can be stationary or it's just spinning freely. So it's just not engaged in the system. And then last is direct drive, which is that any 2 members of the system are locked together. So now you can have your sun and your planet, or your annulus, your planets and your sun, but you've got an input and an output, and it's causing the entire system to actually rotate. So that's a direct drive system. Now these are important. These are things I want to emphasize because these 5 different laws come into play with one of your questions as to why something would be stationary. In your particular question, it was the actual ring gear itself. You would keep that stationary because you're trying to achieve something, or whatever it is you're trying to achieve in your system, whether it's going into neutral, whether it's going to overdrive, underdrive, reverse, or direct drive. Depending on what you're trying to achieve is what you're going to actually lock up into place. Now, so again, discuss what's the benefit of having your ring gear stationary or move freely. Well, this gets us back to the configuration of the planetary gear sets. Now, I just talked about those 5 rules and why you would want to have them set freely, but a lot of times you don't have the benefit of going in and changing your system. So what happens is we tend to want to, or we have designs for specific gear sets that actually do specific things. So here on the left you have a reverse gear set. That's the sun gear. Sun and ring gear are the inputs and the outputs. So you can see in this diagram, you've got a series of splines going from here and attaching directly to your sun gear. So that's either an input or an output. And up here at the top, you've got teeth on your ring gear, the teeth of your ring gear, and you got splines on the outside. Again, that means that you've got an input and an output from either the sun or the ring gear, and your carrier is not engaged. Over on the left, it's a little more difficult to see. Another picture I snagged. You've got an output shaft here, and that's your planet carrier. So your carrier has an output shaft, and up here you've got an input shaft, and this is based off of your ring gear. So your ring gear is out here, which is the input, and in this case you've got your carrier, and these are your planetary gears, and that is your output shaft. So the benefit of having, your stationary gears, your ring gear, or any of the others for that matter, is dependent on what you're trying to get that particular gear set to do. So now those are both gear sets, and they both have sort of a dedicated ability. So what do you want to do? So what happens when you want to be able to have a more complicated system, more complicated movements? Well, now you have to deal with multiple gear sets, put into series. So again, this answers one of your questions. The benefit of having the input and output collinear. So what is the benefit of that? Well, now you can build a series of gear sets. So you got a series of gear sets, and you can accomplish a lot of different tasks. So here we have a planetary gear set, a planetary gear train, multiple gear sets. Each one of these setups here are letting us see a different set of planetary gears. They're mounted together, and as you can see, they are collinear. They all have the same axis. Okay, so there's an input going directly to an output, so there's probably being driven from a motor onto some other output, some sort of prime mover that you're trying to get. Now here's a cross section of that, just to give you a little bit better vision of what you're seeing here. You've got again a spline system. Here you have a sun gear. You got some planetary gear. So this area here is your actual carrier, and here you have the ring gear mounted to the outside, and it just goes back and repeats itself. So what you have here, the benefit of keeping these things collinear, is you're able to accomplish several tasks based on what that particular planetary gear set can do. So what you can do is you can actually engage the different gear sets by either locking something up, and causing a particular gear set to drop out of the system, or freeing something up and causing it to actually engage the system. So you can, and that's how you can have an entire gear system and actually cause it to go into reverse, or one of the methods. There's several methods of causing it to go into reverse, or go forward, or just being able to attain a different type of speed. So depending on what you want to lock up, or what you want to, hold as stationary or reactionary, to use more technical terms, helps dictate how you're actually going to operate your mover. So thinking of this as a tank or as a car or some other big vehicle, that would be the application, to your question. Now, I'm going to break this up into two videos. So this video, I went through all the components, how they lay out, what they're supposed to do, and giving you some of the proper names. In the next one, I'm going to go through some of the calculations. And I'll post you a video going through some of the calculations, because the calculations for gear ratio on planetary gears is a bit more complicated than it is when we're looking at sets of gears like helical gears or spare gears together. Alright, so I hope this was helpful. If it was, stay tuned, go ahead, subscribe to the channel, and I'll have the other video up. Probably will end up being next week sometime, but I want to go through that, and you can subscribe to my channel and get it automatically. You can also see several of my other videos on mechanical design and manufacturing and other applications. Alright, thanks for the email, Zach. So if that video was helpful to you at all, go ahead and subscribe to my channel. I do videos on manufacturing as well as different engineering topics. Please share the video to anyone you think might be able to benefit from it. So you can subscribe to me on YouTube. You can also follow me on Twitter, where I go through a lot of different engineering and manufacturing topics up to date, talking about the skills gap and Industry 4.0, or the fourth industrial revolution. You can also follow me on Google+. I have two fairly active communities. One is manufacturing skills and education, where I talk about obviously manufacturing and manufacturing skills, manufacturing technology, and I try to help people showcase their companies on that channel. And then there's the Engineers Reference, where I talk about general engineering activity, a lot on automation, a lot on just like new technologies and different types of math applications and different things that engineering goes through. So another pretty active community. And anytime you see my little logo, the infinity, double infinity, you can know that I've got my presence there. Again, thanks for watching, and I'll see you on the next video.